Hello friends, today my topic is n factor. Now what is n factor? N factor is the number of electrons lost or gained per mole of the substance, and that is the important tool to find out equivalent mass. And the importance of equivalent mass we can understand in the next lecture. Now first try to understand what is n factor. Now if I want to understand n factor for sodium, magnesium, aluminum, that will be 1. For magnesium, it is 2. Aluminum, it is 3. So it means we are 100% sure when they react, they lose 1, 2, 3 electron respectively while they react with the other substances. So there is no, confusion in that. Now, if you take some other element uh, which can lose electron differently in different reactions or under different circumstances, then their n factor changes. So in that case, if he loses 2 electrons, his n factor is 2. If loses 3 electrons, n factor is 2. And same for tin. Sometimes it is 2, sometimes it is 4. So definitely, these are all mostly linked with valency and variable valency. So you should have good knowledge on valency or variable valency. Then only n factor can be clear to you. Now for ions, especially ions of single atom, the valency is seen on the charge, and for them, n factor is very easily can be calculated. So for sodium, it is 1. You can see this, it is particularly written over here. For Fe, it is 2. It is 3. For same chromium, it can be 6 also. So it is based on the charge. It means already they have lost 6 electrons. I'm talking about the last example, chromium. And so its n factor is 6. So for ion of an atom, calculation of n factor is very simple. Now coming to the n factor of salt. Now, if you try to understand the formation of AlCl3, then separately you can write it like this: aluminium plus Cl2, 3 by 2, and they are converting into AlCl3. So during this process, you can see this total electron lost by aluminum is 3 electron. Okay, that is lost. And total electron gained by chlorine is 3 electron. So in both the cases, you can see very carefully, there is 3 electrons are lost and 3 electrons are gained. Definitely it happens in every cases. Electron can be wasted. So in that case, your n factor will be 3. So I can personally suggest you just track number of electrons lost by metal, because tracking that it is a little easier. But of course, you can look at the negative charge as well. For magnesium, also same thing. You can understand, if you take magnesium and if you can take chlorine, then you'll find MgCl2 formation. And in that case, magnesium is, losing 2 electron, and chlorine is, both the two chlorine I'm talking about, it has gained 2 electrons. So in that case, n factor is 2. Now coming to the n factor, where oxidation number can change in a very different manner under different circumstances. So for that reason, you need to have real equation, and then by looking at the real equation, you can just calculate that. Let me show you how it goes. Now I need to calculate n factor of Ca2O7 minus, I think potassium dichromate or sodium dichromate. Now you can see charge or oxidation number of chromium is +6 here, and here +3 here. Okay. Now what is the difference? You can see the difference is basically 3. Okay. 3 is the difference. Now 3 is the difference for one atom, but there are 2 atoms present. So you need to multiply 2. So it is coming out to be 6. So here n factor is 6. Now question arises, it means potassium dichromate or sodium dichromate, they have always n factor 6? No, it's not the case. Now if you take another equation, now in this case, of course, valency of chromium remains same here in the left hand side, that is plus 6. Here it is plus 4. So changes are 2 electron or 2. For 2 atoms, it will be 2. It is 4. So in the second case, n factor is coming out to be 4. Okay. So it means you cannot say n factor of potassium dichromate will be always 6. Mostly it is 6 because this reaction is famous. It happens in acidic medium, but it can be some other value as well, depending upon in which oxidation state it is converting into. Now, tracking n factor for disproportionation reaction is little difficult because atoms of the same element going into different oxidation state. So it appears to be a little difficult. In that case, you need to follow one formula. Let me write it down. Formula is N1 into N2 divided by N1 plus N2. Uh, N1 stands for N factor for oxidation and N2 stands for N factor for reduction. Let me explain how it is going on. Let's take this example here. So now you can see this. This is definitely reduction, and you can see the difference in the oxidation number is 1. For 2 atoms, it will be 2. So it is coming out to be 2, and that is nothing but N1. Okay. Now coming to the second case, that is when it is going into plus 5 oxidation state. So I need to do it from the down. Yeah. Now you can see this difference is 5. For 2 atom, it is into 2. It is coming out to be 10. Okay. Now this is nothing but your N2. So n factor will be here N1, that is uh, 2. N2 is equal to 10 divided by 2 plus 10. So it is coming out to be 20 plus 12 is equal to. So this is the n factor for this particular reaction. Take another example. Now in this case, n factor for reduction is coming out to be like that. So difference is 3. For 4 atoms, it will be into 12. Okay. So this is nothing but your N1. Now coming to the second case, that is the oxidation case. You can see difference is 1. For 4 atoms, it will be 4. Okay. That is nothing but your N2. So N factor is coming out to be N1 into N2 divided by N1 plus N2. So it is coming out to be 12 into 4 divided by 12 plus 4. So I hope you have understood how to calculate n factor for disproportionation reaction. Now I'll take n factor where both oxidation and reduction going on simultaneously, or only oxidation going on for different atoms, or atoms from different molecules as well. Let's take. Now this example is showing oxidation going on for both arsenic and sulfur in the same compound. So here how to calculate n factor. So now see the difference between these two. Here you can see this number of electrons lost, 2 electron. Okay, how many atoms are there? 2 into 2, that is minus 4. Okay, that is our N1. Okay, now coming to the case of sulfur, you can see this. How many electrons are lost? Minus 2 to 6. So minus 2 to 6, how much it is? It will be? It is actually 8. If you're not understanding, let me explain this. This is the scale, okay? So that is minus 2, then minus 1 plus 6. So in that case, you can see 1, 8. So n factor here, I mean, changing the oxidation number coming out to be 8. You can say this, and for 3 atoms into 3. So that is minus 24. That is n2. So now here, what will be the final n factor? Final n factor will be minus 4. I'm putting minus n because the electron is lost, plus here minus 24. So it is coming out to be minus 28. But minus n I'll not put, because minus n just indicating that electrons are lost. That is my way of tracking that. So definitely those electrons are gained by some other element. But so remember, you need to only check how many electrons are lost or gained. If you can see, if 20 electrons are lost, then definitely some other side 20 to 28 electrons will be also gained. So that way, I don't need to put minus sign. So our n factor in this case is 28. Now you can see in this case, I have written all oxidation state, and of course, oxidation reduction both are going on simultaneously. So, but I don't need to track both. I need to only track oxidation part or reduction part, because in oxidation, if X number of electrons are lost, then in the reduction, X number electron will be gained, and X is our n factor. So what I'm going to do, I'll just track the oxidation process here. So first, let's check first oxidation process. That is, in this case, it is going from plus 1 to plus 2. So change in the oxidation number is minus 1. And of course, for 2 atoms, it is minus 2. And that is I'm labeling as N1. In the second case, here oxidation case, this is sulfur I'm taking. This sulfur is going to minus 2 to 4. So it's a difference is 6. Okay. So minus 6, and that is, and the number of atoms 1. So this is I'm leveling N2. Okay. So now n factor here coming out to be in this case is equal to N1 plus N2. Just a second. N2. And of course, it should be modulus value. Negative sign has no meaning here. So 2 plus 6 is equal to 8. Now let's take the last example. So relatively, finding n factor for salt is very easy. Only you need to count total positive charge or total negative charge. Okay. So in that case, you'll find uh, here it is plus 1, and for 2 potassium it will be plus 2. Here oxidation state is plus 3. For 2 aluminum it will be plus 6. Okay. So now this is I'm leveling as N1, that is N2. So when you add them up, it will coming out to be N1 plus N2 is equal to 2 plus 6 is equal to 8. So with that, we have come to the end of this very important and delicate and to some extent difficult concept. And it will be immensely useful in our next session, that is in equivalent mass, and for the calculation of anything where equivalent mass can be used as a tool to track amount of substance involved in the reaction. So till then, bye bye, take care.